Linear graphs, lecture 2. So in the first lecture of linear graphs, we have seen how to plot a single straight line graph when some linear equation is given. Now in the present lecture, that is the second lecture of the linear graphs, we will explore the skill how to plot piecewise graphs, or you can say line segments. What is a piecewise graph? If you see this blue line graph, so it is not a single straight line. Can you see? The first segment is horizontal, the second segment is slant, and again the third segment is slant downwards. So such a graph of a straight line is called piecewise graph or line segment graph. The graph can be continuous, like in this graph. What is the meaning of continuity? Suppose you are keeping a pen on the graph and you are traveling with the tip of the pen and the pen is never leaving the graph. You need not to pick up the pen. Then we say the graph is continuous. Like in this figure, in this graph, you can see this light blue graph is continuous in nature. It has no breaking point anywhere till the end. Or the graph may be discontinuous. If you see this kind of piecewise graph, we have two line segments and there is a discontinuity. If you are, traveling with the tip of the pen, you have to pick up the pen at this point to again keep it on the next graph. So the piecewise graph can be continuous or discontinuous. Number one. Number two, what is a piecewise graph? Which has different segments of a straight line. When we are talking about piecewise graph, in context of a straight line, there are other curvilinear graphs too which can be piecewise. Right now in this lecture, we are limited to straight line piecewise graphs. So they are breaking in different segments of a straight line. So in today's lecture, we will see if we are given the set of equations for piecewise graphs, then how we are going to plot these graphs, okay? Let's see a model of the description of a piecewise graph. Suppose in kinematics, we are given the variation of the velocity with time by two linear equations in different sets of time. Say the velocity is given as 2t when the value of t is between 0 and 10 seconds, and further when time exceeds 10 seconds, the velocity is 20 meters per second. So you can see both are linear graphs, and when we will have the plotting of the velocity time graph, we will get something like this. So here you can say it is a line segment graph or a piecewise graph. So in today's lecture, we are going to explore the skills which will help us to plot these kind of graphs when such equations are given in different sets of values, okay? Now, first of all, let us see what is a light, or on casual note, what is the meaning of the domain of a function. We are not going for the definition or technical way of defining the domain as we do in mathematics. We are limited for the application point of view in physics, so we will restrict ourselves as to understand what is the domain of the function when we consider some function. So say if we have y as a function of x, always in our prototype we take y as a function of x. So if we have y as a function of x, then for different values of x for which the function is defined or meaningful is called the domain of the function, okay? It's called the domain of the function. Suppose for illustration, y is equal to root x, okay? Now we know if we take x to be negative number, y will not belong to be a real number. So if y need to belong to be a real number, so x must be greater than or equal to 0. So for this function, the function will have some meaning or definition only when x is greater than or equal to 0, okay? So this is basically the domain of this function. So domain is basically, in a simple language you can say, domain is the set of values of the independent variables for which the values of the dependent variable is defined in the function, okay? Like if you see this illustration, so here the independent variable is t, correct? The independent variable is t, the dependent variable is v, so v is a function of time. So the values of t which are constituting the meaning of the function is called the domain of the function. So here you can see the velocity is equal to 2t when the domain is between 0 and 10, when the value of t is between 0 and 10, and the velocity is 20 meters per second when the domain is greater than or equal to 10. So this value of t is constituting what? The domain of the function. So in a simple way we can say, if y is a function of x, then the values of x for which the y function is defined is called the domain of the function. Got it? Now in piecewise graphs, when you are talking about piecewise line segment graphs, the function is described by different rules for different parts of domain. So whenever you are describing a piecewise function like this, so say we are describing velocity by different rules, by different laws, by different equations for different parts of the domain. It is not same for all values of t. Can you see? When t is greater than or equal to 0, less than 10, velocity is 2t. When t is greater than or equal to 10 seconds, velocity is 20 meter per second. So whenever we have a piecewise function, the function is described by different rules for different parts of domains. Like if you say, consider a part of the domain, say x is greater than or equal to 4 and less than 10. And for this domain, the function is described as y is equal to 3x plus 5. See here, the value of x is including the value of 4 but excluding the value of 10. Now if you want to plot this graph, we have seen in lecture 1 how to plot a single straight line graph. So if I'm plotting here y versus x graph, and I'm just plotting the vertical lines at the end points of the domain for which this rule is defined. So this is defined for this, so I'm plotting a value of 4 as the initial point and the value of 10 as the end point, correct? Now y is equal to 3x plus 5. Now as we did in lecture 1, if you compare it with y is equal to mx plus c, so the coefficient of x will give the slope which is 3, positive, line will go up as you move right, and the intercept is 5, but we can't make the direct intercept, correct, because we have to start the graph from this line, from the value of x. So let me find what will be the value. It is very simple. You can find the value when x is equal to 4, y will come to be what? You can see y will be 3 into 4 plus 5, that is 12 plus 5, that will make how much? 17. And when x is equal to 10, y will be what? 3 into 10 plus 5, that is 30 plus 5, that makes us 35. Okay, so I'm plotting the two end values of y. I'm plotting two end values of y as 17 and 35. Got it? And I need not to make all the plotting, and neither I need to make the plots according to scale. When I'm making the graph, we are making a freehand sketch and only the relevant points. So 17 and 35. Now when x is equal to 4, y is 17, and this value is included. Can you see? There is a equal sign. So here the graph will be a straight line going up, and here you will make a dark circle. This dark circle is denoting that at x is equal to 4, the value of y 17 is present. Okay, and however the value of 10 is excluded. So here you will make a hollow circle. The hollow circle is denoting that x is equal to 10 is not included in this particular line segment, and your graph will be something like this. Okay, so this is the illustration of making one piecewise graph between 4 and 10. 4 is included, where you are getting the value of y as 17. 10 is excluded, that's why we are making a hollow circle, and here the limiting value of y is 35. Got it? So this will be the skill which we are going to use in plotting the piecewise graphs. Got it? Now let's see. Whenever we have a piecewise graph, already we have seen the function will be described by different set of linear equations in different set of domains. So suppose, just to illustrate a format, suppose we have y as a function of x, and we have here different domains, say between 0 and p, when these are what? These are different set of domains. So when x is lying between 0 and p and both are included, then the function is described by, say, a linear function ax plus b. When x is greater than p and less than or equal to q, say the function has the format cx plus g. And finally, when you are in the range of x between q and r, the function has something like gx plus h. All three are linear functions. So just by the sight of the three piecewise linear equation, you can visualize that graph of y. When you are plotting the graph of y with x, you will get different line segments. You will get three different line segments and all three will be line segments, a straight line, because all three are linear functions. So here we can see that y is described by different linear equations in different sections of domains, values of x, that is simple value of domain. And so the graph of y versus x will consist of multiple line segments to corresponding domains. So for each set of domain, we will have a specific line. Okay, and note one thing, be careful about the endpoints. Be careful about the endpoints. Never have two closed endpoints directly one over the other. What it means, see, you cannot have the overlapping points. Like, see, when you are attributing the value of x as p to first equation, you are not including p in the second equation. Here you can see x is less than or equal to p, and here you can see x is greater than p. So you have to be careful about this point. You have to be critical about the endpoints. Key that endpoint is getting in which piecewise description. Like in this case, p, when x is p, the function y will have a value defined by equation 1, and when x is greater than p or less than equal to q, the function will be defined by the value 2. Got it? Now let's see some illustration how we plot. See the illustration. Sketch the graph of y against x if. So let me first make the coordinate system, and no restriction is given, so I will assume I will be plotting x from minus infinity to plus infinity. Of course, practically we won't go to minus infinity or plus infinity, but no restriction of domain is given, so there are no uppermost and lowermost endpoints of x. Okay, so 1 is the changing point of x. You can see the behavior of the function is changing at 1. So what I will do, first step, I will make a vertical line to remind myself that I have to be careful while passing this barrier. Okay, this is 1. Okay, now see, when x is less than 1, the equality is not present at 1. So when x is less than 1, we have y as a constant function. So let me go a little below also, because we have to get some negative value of y, correct? So when x is less than 1, we have a value of y as what? Minus 2, and 1 is not included. So I'm making a line through minus 2. This is a value of y as minus 2, and here I'm making a hollow circle. Why I'm making a hollow circle? Because when x is equal to 1, this value is not included in this yellow graph. Okay, and when x is greater than or equal to 1, we can see y is again a constant function equal to 3. So what we can do here, and 1 is included in this part, so I can go like this, and of course it will go to up to infinity, so I need not to worry about the endpoint. And here I'm making what? Here I'm making a dark circle to denote that the value of x is equal to 1 is included in this description. Got it? And if you want, you can make a dotted line here to denote what is the corresponding value of y here. So this is equal to 3. So you can see this illustration, we have a simple piecewise graph. And what you can say, whether the graph is continuous or discontinuous, clearly you can see the graph is discontinuous in nature. Here we have a breaking point. Okay, so this is the first illustration. Now see the next illustration. See, we have again a piecewise function, and you can see here y is described in 3 different segments. We have the first segment for this part of domain, second segment for this part of domain, and third segment for this part of domain. Okay, so basically first step, what I will do, I will make the coordinate axis, and I will make the endpoints where the behavior of the function is changing, and we are starting from 0. So I need not to go to much left, okay, because we are restricted for the values of x greater than or equal to 0. So first behavior changing point is 5. So I'm just making a line at 5, then 8, okay. And I need not to measure, okay, don't be worried that we have to exactly measure. You simply need to make freehand sketches, okay. And then 10. Of course, you can take approximation like this. If this is 5 and then you're going for 8, so this would be less than this. Just you can do, and then we have 10. So I'm making the 3 plots here, and this is what? 5, then we have 8, and then we have 10. Okay, we have 3 values of x. Okay, now come to the first segment. Now first segment is between 0 and 5, and in this segment 0 is included but 5 is excluded. So at 5 you will make a hollow circle on the graph, at 0 will make a dark circle because that point is included in that graph. Now in first segment I can see first line segment I have the equation when x is between 0 and 5. So I have y is equal to minus x plus 6. Okay. Now we know the basic skill of making the graph. If you compare it, y is equal to mx plus c. So m is coming to be minus 1 and c is coming to be 6, correct? So the line will go downward and the intercept will be how much? 6. And it will go till where? Till 5. So at the initial point you can directly find the graph. If you see x is equal to 0, y will be equal to what? 6. And this you can also find by the intercept even without calculating. That's why I've written earlier too. You see y is equal to 6. So this is the initial point for segment 1, and the final point is what? 5. That is the final point. So what is the final point? 5, and at this point y will come to be minus 5 plus 6. So y will come to be 1. So I can make the first line. Let me make a dotted line here roughly, which is denoting the value of 1 because I have to stop at 1 and I have to start at 6, and the line will go down since it is having a negative slope, something like this, correct? As I told you, at 5 I will make a hollow circle, and at 6 I will make a dark circle because this value of x is included. That is the segment 1. Okay. Now between 5 and 8 y is equal to 1. So in segment 2 the value of x is greater than equal to 5 and less than 8, and y is equal to 1. Now it's a constant function. In fact, you see it is independent of the value of x, so you need not to worry about the intercept or slope. It will simply go at 1. So I can extend the graph, and again I will make a hollow circle here, and since this value get included in this graph, and it is also coming to be 1, so we can make a dark circle at this point, taking the contribution of the second segment graph. Earlier it was hollow circle because earlier that was the end point of segment 1. Now it is also the beginning point of segment 2, which is including x is equal to 5. Okay, then we will come to the third segment, and the third segment is between, we will go for finally segment 3, x is greater than equal to 8 and less than equal to 10. Both the values are included. We are coming to the end point of the domain. So we will get y is equal to 0.5x minus 3. Now see, if you compare it, y is equal to mx plus c. So your slope is coming to be 0.5, correct? And intercept is coming to be minus 3. But since I am making the line ahead, not in the first segment, to intercept directly I cannot make the intercept. Had the line been in the first segment, like in the first segment the intercept was 6, so it was easy to make the line, straight line green graph cutting the y-axis at 6. But when the piecewise graph is in the second, fourth, third, or subsequent segments, and it is really not cutting the y-axis, so just by intercept we cannot make the graph. Either you have to project it backward or you have to find the values. So first of all, let's see what will be the inclination of the graph, correct? So what I can do, slope is positive, so line will go upward, surely it will go upward, correct? And if you see, when x is equal to 8, that is the initial point, let us find the value of y. So y will be 0.5 into 8 minus 3, so I'll get 4 minus 3, so the value of y will come to be 1. And when x is equal to 10, that is the final point, correct? So y will be equal to 0.5 into 10 minus 3, that is 5, minus 3, that is 2. So line will go up and it will go from 1 to 2. So what I can do, I can make one more line here, plotting this as the value of 2, or you can make a little below, because this is 1, this is 6. So approximately this will be 3, approximately, not going by the scale. So 2 will come something like that, below the half point, correct? 2. And since both points are included in the third segment, so we'll get a straight line graph like this. And here we'll make a dark circle because 8 is included in segment 3, and at x is equal to 10 we'll also make a dark circle because this is also included in third segment. So this will be the final graph, piecewise graph for this description of y. Got it?